This is Gabriel Galarza. I'm doing my grading replacement for number 4552, and this is for test number 2. And for number 52, we are asked to draw a parabola, which I did right here, in which y equals x squared. And on a parabola, I marked a point that was not the origin, and it has to be the normal line. Draw it through the normal line of this x squared. And here it says the normal line intersects the parabola at another point, which is Q, which I have right here, and show the distance between P and Q minimized by the setting that P is equal to plus or minus square root of 2 over 2 and 1/2. So to do this, I started off by going ahead and writing down my distance formula because they were asking me to minimize the distance. Okay, and here, the next thing I'd have to do, I would have to find the equation. So I went ahead and figured out the slope for the tangent line right here, which is the derivative of x squared, and I found it to be 2x. So in order to find the normal line slope, I went ahead and found the reciprocal of 2x and made this to be negative 1/2 x. So for the normal line, I went ahead down here. I'm going to go ahead and write down the slope that I have and put b as the intercept. So in order to go ahead and find the b, I went ahead and plugged in the plus square root of 2 over 2 because negative is not able to be a distance. You can have a negative distance. So I went ahead and used the positive distance. So here I went ahead and plugged in the x. So negative 1/2 times square root of 2 over 2 equals 1/2 plus b. Once I went ahead and solved this, once I went ahead and solved this, I went ahead multiplied this out. Negative square root of 2 over 4 plus b equals 1/2. I went ahead and added this over and got 1/2 plus square root of 2 over 4 equals b. Then I went ahead and found a common denominator and made this to 2 plus 2 square root of 2 over 4 equals b. So this would be the intercept of the y. So overall, the normal line was y equals negative 1/2 x plus 2 plus 2 square root of 2 over 4. And that is my normal line right here. Once I found my normal line, I went ahead and used the distance formula and plugged in everything that I needed. So we already know that we have these points right here, this x, x1, and this y, x2. Correct? And so what we did is we went ahead and plugged those numbers in to the distance formula. D equals square root 2 over 2 plus x, which is the x that we're looking for, over 1/2 plus x squared over squared. That is the distance formula right here. After going ahead and foiling all that out, I went ahead and ended up with the square root of 1/2 plus square root of 2 plus x squared. Subtracting all that by 1/4 plus x squared plus x fourth. I'll go ahead and fix that out. So, oops. There you go. I'm separating that for you. And then after I simplified the entire thing out, the distance formula, I ended up with 1/4 plus square root of 2 minus x to the 4th. So I went ahead and derived this, and after I derived this, I ended up with with this right here. Use chain rule and ended up with so that is what I get after deriving the distance formula, and that is the minimized distance by setting P equal to this. So once again, after deriving the distance formula, I found out that this is the distance between P and Q. This is the distance between P and Q, minimized with parabola y equals x squared.